So we just got done solving exponential equations. Remember when we kind of either found the same base or we put logs on both sides and went from there? Well, now we're going to be solving logarithmic equations. Okay, they work completely differently, but there's one key rule to remember in a lot of these problems. And that rule is, if you go back a couple videos before, a couple notes from previously, and we talked about if we had b to the log base b of x, or it doesn't really matter, but of something, that just equals x, because b to the log of base b power, those things cancel out. Those things are inverses and undo one another. We're going to be doing that, or coming back to using that rule a lot in this video. So, with number 7, we're going to start with that exactly. I'm going to try and solve this logarithm. Now, one thing that's kind of in my way is the logarithm itself. An easy way to, I guess, cancel that out is to make that logarithm an exponent. So, notice how the base is 3 here. Well, if I take 3 and I raise it to the logarithm with the base 3 of x minus 5, right, equal to, now of course if I do that to the left side, I have to do it to the right side as well. I'm going to make 3 also the base of this, and then 2 the exponent. So basically, I've converted this and this to exponents of 3, right? 3 to this log power, and then 3 to the second power. It's basically what I've done. And the reason I've done it is because now 3 with a log of a base 3, those things cancel out. Meaning that this side on the left is really just x minus 5. And on the right, I have 3 squared, but I know 3 squared, right? Because 3 to the second power is 9. So I really just now have x minus 5 equals 9. So add 5 to both sides, and we're done. X equals 14. All right? So it was a little bit of clever thinking and creativity that got me there. But what I did, again, just to recap, is I made this logarithm, oops, choose a highlighter, I guess. I made this logarithm an exponent of 3 because I knew that 3 and this logarithm that has a base of 3, I knew those things could cancel each other out. That's why I did that, okay? So they canceled out and I got left with x minus 5, but of course, whatever you do on the left side, you also have to do to the right side. So that's why I had to do the same thing on the right side and make 3 the base and 2 the exponent, okay? So, let's try this on another problem, shall we? Alright, now this one's a little bit different, but notice we have log 45x minus log of 3. Now that might ring a bell because there's one property we talked about where we subtract logarithms, but when we subtract logarithms, we don't actually subtract them at all. If I want to write these logarithms together, the subtraction really means I'm going to divide these logarithms, or at least divide these, right? So this would be the same as log with 45x divided by 3. Right, I'm subtracting 2 logarithms, but when I'm subtracting logarithms, I could combine them really by dividing the values in the logarithms. Right, so go back in time and watch that video if you don't remember that. That's one of the properties we talked about. The property where we said log base b of m minus, log base b of n would equal log base b of m divided by n. So the minus sign means you take m and n and you divide them. Alright, but anyway, so I've combined them on the left. I didn't do anything to the right side. It's still equal to 1. Also, though, I can simplify 45x divided by 3. Well, that's the same as 15x. So this is really just log 15x equal to 1. And now I'm going to do what I did in number 7. Because I have this logarithm. Now keep in mind that this logarithm has a base of 10. It's not written there currently, but you still know it's 10. If I want to undo this logarithm with a base of 10, what I'm going to do is I'm going to raise that to an exponent with a base of 10. So I'm going to put 10 down here and make that an exponent, but I also have to do it to this side as well, make 1 an exponent. So that's how I'm going to write this next step. I'll have 10 to the log base 10 of 15x equal to 10 to the first power. So I'm making both of these exponents, all right, exponents with bases of 10. And why did I choose a base of 10? I chose to use a base of 10 because that had a base of 10 in it, right? These need to match for them to cancel out, and that's exactly what will happen now. 10, log 10, that cancels. Let's go back to my pen, please. All right, leaving us just with 15x on the left side equal to 10 to the first power on the right side. Now 10 to the first power is just 10. So our equation is really 15x equals 10. 15x equals 10, then you divide by 15, and you get x equal to either 2/3, you could write it as 2/3 because that's a simplified version of that fraction, or as a decimal be 0, I guess, 0.66, and so on repeating. Okay. Now something I want to do, I'm going to pause real quick before I do anything else. I'm going to take my calculator and plug in my answer that I got for number 7, which remember 7 I think was x was equal to 14, and now number 2 I'm saying x is equal to 0.66, right? So let me get a calculator and just plug them in and show you that it works. So with number 1, it was log base 3. Now this, I guess, will only really, I mean, you could do it without this graphing calculator, but this calculator thankfully already has the base log function, so I can change the base to 3 there. And then x minus 5. Now x was 14, so we're going to put 14 minus 5 in the parentheses. Right, so that's the same as number 1. I'm going to hit enter, and I'm going to see if it equals 2. It should equal 2. Right, so that's how I know I was right. X was equal to 14. Now for the second example, I had log 45 times x. So we're going to have log, and then we're going to do 45 times, now x was equal to 2/3 or 0.66. So I'm going to write this as just 0.66. I'll just put a few in there. So keep in mind that's not the exact answer because that 6 is supposed to go on forever. So it's going to be close, the final answer, but we'll see how close we get. Minus, what was it? It was minus log 3. Log 3. And we should get an answer very close to 1. Yeah, 0.999, right? If I put exactly 2/3 in there, which I can, let me see if I can do that real quick. Log 45 times, and I'll put 2/3 as a fraction, 2 divided by 3. So that's a little bit different. I didn't want to do that necessarily the first time because I know we have a hard time putting fractions in our calculator. So that's why I used a decimal the first time. But now I put in the exact fraction, 2/3, so I should get the exact answer 1. Right. So it works. So that's a good way to check your answer, is by plugging it back in and seeing if it comes out accurately or not. So let's try number 9. All right, number 9. Notice we have a log with a base of 4. So what I'm going to do is I'm going to raise these with bases of 4. Make this 4 to the log base 4x squared equal to 4 to the 7th power. So I've converted this equation. I've made both of those things exponents, and I've made them both exponents with bases of 4. Again, I chose to use the base of 4 because I knew that I could get them to match, and when they do match, that means this whole thing cancels out and leaves the left side as just x squared equal to, well, 4 to the 7th power. I'm going to need a calculator to get 4 to the 7th power. So let me do that real fast. Four to the 7th power equals 16,384. So it's a big number, but it's all right. So this is x squared equals 16,384. Now I have x squared. So what I'm going to do is Well, the opposite of squaring something, which is square root something. So I'm going to square root this, and I'm going to get x equal to, now because I'm square rooting it, there's actually two possible answers, a positive and negative version of this. But the square root of 16,384, that's 128. So technically x equals positive and negative 128. However, only one of those answers might actually work as a solution. So let me try that on the calculator again and see if it does. Let's confirm it. So I had the logarithm with a base of 4. So we're going to type in logarithm with a base 4. And we had x squared, right? So we're calling x, let's use a positive 128 for now. 128 squared, right? And that should equal 7. Okay, so equals 7. Let's hit enter, and it equals 7. So I know 128 is good. But the other one is a negative 128, right? X can be both positive or negative 128. So let's see if the negative 128 works. So let's go back to math, get our log base function, change the base to 4, and let's try negative 128 squared. Now you'll notice I put extra parentheses on that because whenever I square a negative number, to make sure I do it properly, that number has to be in parentheses. And I had two sets of parentheses because I got one for the negative 128 and then one to keep the squared inside. I can't put the squared outside the parentheses. It wouldn't work that way. But we get 7. So it does work, both negative 128 and positive 128. So there are technically two answers here. Okay, both positive and negative 128. And again, the reason it's positive and negative is because, well, as we just saw, 128 squared is 16,384, but negative 128 squared is also 16,384. So technically, because two numbers you can plug in for x to equal the same thing, both those numbers could potentially be x, so both of those numbers are answers. Okay, so that's why you kind of have to just remember the plus and minus when you take square roots. All right, well, let's try number 10. So number 10, I'm adding logarithms, but again, when you add logarithms, you're not actually, if you're going to combine this into one, you're not actually going to add them, you're going to multiply the pieces of them together. So this would be log, and you're going to take x and times it to x plus 9. Now I put x plus 9 in parentheses because it is kind of one thing that goes together. All right, and that's still equal to 1. Now notice, if I'm going to multiply x with x plus 9, I have to distribute this x to multiply it correctly. So it's going to be log, x times x will be x squared, and x times 9 will be 9x, equal to 1. All right, so again, remember, we want to get rid of the logarithm. Notice that this logarithm is a common logarithm, meaning it has a base of 10. So what I'm going to do is I'm going to make both of these exponents with bases of 10. This will be 10 to that logarithm as an exponent, and then the right side will be 10 to the first power. So let me write it this way. 10 to the log with a base 10, x squared plus 9x equal to 10 to the first power. Now, the whole reason I'm doing this is so that I can cancel that logarithm out. And I just have x squared plus 9x equal to 10 to the first power. But 10 to the first power is just 10. All right, so unfortunately, I ran out of room, so I'm going to have to erase and put this back up here. But this is where we're at right now, right? X squared plus 9x equals 10. I'm just going to rewrite that. X squared plus 9x equals 10. I'm trying to solve this for x. So this is a quadratic now. So we have to solve this like a quadratic. When we solve this like a quadratic, we need this in ax squared plus bx plus c equal to 0 form. So I need to move this 10 over here so I can have 0 on the right side. So that means subtracting 10. That'll leave me x squared plus 9x minus 10 equal to 0. And now there's a couple ways you can do this. You can solve this quadratic using either the quadratic formula, or you can try and solve it by factoring. Factoring can be faster, so I'm going to go ahead and do it that way. If you're factoring, you have A equals 1 here, B equals 9, and C equals negative 10. So 1 times negative 10, A times C is negative 10, and B is 9. So I need two numbers that multiply to negative 10 and add to 9. And I believe that would be 10 times negative 1. 10 times negative 1 is negative 10. 10 minus 1 is 9. So we're good. Now because A equals 1, these are the factors. So this is really the same as x plus 10 and x minus 1 equal to 0. Which means if you set these both equal to 0, x plus 10 equals 0. You're going to have x equal to negative 10. And then if you take x minus 1 equal to 0, you're going to have x equal to positive 1. All right, so we have two solutions again. It definitely took a while to get there, but we have two solutions, and we want to check to make sure they both work. So let's use the calculator again. Let's plug in the negative 10. Let's plug in 1 and see if they both work. So we had, where is it? Log x. So let's try the negative 10 first. So log negative 10, it was plus, what was it again? Log x plus 9. So log, and this will be negative 10 plus 9. Right, I'm just plugging in negative 10 where I see x. All right, and if I should hit enter, it should equal 1. Okay, didn't necessarily get 1, so maybe negative 10 is not really a solution. What if we try the other solution we got, which was a positive 1? So, log of 1 plus log 1 plus 9. All right, equals 1. All right, so that means negative 10, although it came out as a solution when we solved it, it's an extraneous solution. It's a solution that doesn't actually work, even though it's one that came up as an answer. 1 is really the only solution because, as we just verified, it's the only thing that I can plug in where it actually would work. Negative 10 was a good contender, but it didn't quite actually pan out to be an answer. So x equals 1 is the sole solution. Negative 10, you had a good go at it, but you aren't actually an answer. You lied. You lied to me, negative 10. X equals 1 is our solution. All right, I'm going to end it there, guys, so the video's not too long. So we'll see you in the next one. I think the next time we'll either take a test or quiz, or we'll try doing natural logarithms. Okay? Well, see you later. Bye-bye.